Hello to 1.4, how to read data or how to read limits on data charts, and that's it. I don't know where I was going with that. Just looking for my tab on my infinite tabs. So here, you can stop the video and try it on your own. Remember, the limits are given to us. We just have to evaluate the limits or the limit of that is going to approach to that. So here, as we can see that the limit is 5 because it's undefined. Undefined. That's indeterminate, my bad. That's the term that you will learn in the next video. Determinates. Like over 0. There will be like an asymptote or something. Or a dot. Or a hole, my bad, on the graph. So, yes. So for this one, it does look like it's going to be like a hole, but it's going to be occurring in this. So yes. So as we get closer and closer from the left side, remember the negatives are equivalent to the left side. Positives are right side. For the limit of x as 5 approaches, uh, the limit of the limit of f of x as x approaches 5, this will, these two have to equal. So remember that. And here we can estimate, roughly estimate that our limit is approaching 75. And here, likewise, we can estimate that it's approaching 75. So since these two agree with each other, we can conclude that the limit of f of x will be equivalent. Give me a second. Sharing here. Equivalent. Equivalent to 75. 75. Let me try to finish this as fast as I can. Since these videos, I notice, have a tendency to go on and on for some reason. Here we have a function, and we're trying to see when x approaches 1 from the respects of each side, left and right. So here I'm going to write it down in calculus notation, or I would say it's calculus notation. I don't know what it's really called, my bad, which I should really know this, but it's okay to not know. That means you're willing to learn stuff, not give up. Here we have two limits. Divisible approach. They're both approaching very closely to 3. Because look, we have 25. That's pretty small. But we get bigger and bigger. maybe a little bit bigger, but we're approaching the limit, which is 1 from the left side. And since we concluded that the limit, we approximated it since we approximated it. And from the right side, it's approaching 3 as well. For this to be not 3 from both sides, um, there will have to be like a significant difference for the limit. So we were given here like 28 and 31, or actually, that's not a good example, like 3.5. There we can conclude that the limit does not exist since these two do not equal. So, yes. Of 1 equal of f of x, remember we have to include um, our function, because if we don't, where are we getting these numbers from? So yes, this will equal to 3. Make sure, yes, so here, here it would probably been undefined, or actually it wouldn't actually, it would actually equal to 3. But since we don't know what's the structure of this graph or the function's behavior, we can't conclude whether it's continuous. Remember, continuous means you don't pick up the pencil from one interval to another interval. This is very important when we have limits that are just not connecting from either or side. Let's move on. From the left side, I'll just rewrite in the bottom. The limit as 7 approaches from the left side of f of x. Since here we can conclude and estimate that uh, it's approaching 8, and the limit of f of x as x approaches 7 from the positive sides or the right hand side, this will be equivalent to, or your limit will approach 8 as well, since these two are equal, or the limits of f of x will equal to 8 as well. I don't know why I pretend I put it in space. I forgot I can do that. So 8 and 7. Here we have another limit. As, as the limit of f of x, x approaches 1. I think this is a repeat, so my bad, we can skip this one. I didn't know say repeated stuff. So let me just erase this and move on to this one, multiple choice. Give it a try and come back. Okay. There's a shortcut for this, but you'll learn it in a later lesson. But I'll give it a glimpse here. We'll just throw out a name. Congregation. Congregation. Remember, I want to become a math major, not an English major, and I don't know how to spell, so I should improve that. Um, Congregation. This just means when you have like square root and it's getting subtracted by like a 4 and you have like a value of 16. We can conclude that we can conjugate this, which will be square root plus 4 the square root of x plus 4. Since this is an example of difference of squares, if you don't know what's difference of squares, it's basically when you have x squared minus 4. When it's something that's getting by subtracted by an x, or it's not a great explanation. My bad. I am very sorry. I can't really explain uh, the difference of squares. Uh, Probably in one video I'm gonna cover it on it properly. So since this is an example of difference of squares, difference of squares just means we can just factor this out by having a 4 and x minus, well, x plus 4, which will equal to this still. So let's continue. Um, you would have to graphically done this by hand, but I'll give you a shortcut. This only works if you're given uh, multiple choice. If they give you this in the free response, please attempt it. Remember, free response are very important. They're like, I don't remember how much percentage because I'm just used with science courses, AP tests. Uh, they're like 60%. No, that's history, my bad. But they're a pretty big part. Since we talked about conjugation, remember we have a radical here. All radicals can be radicals of square root that I know of can be conjugated like this. Since this equals 1, remember, we can manipulate things as long as they make mathematically sense. This is equal to 1, but we just rewarded it. We rewarded 1 differently. So, yes. And remember the limit. I forgot to add this. The limit is 4. Okay. We're gonna do some algebraic manipulation. We're gonna distribute in the bottom the denominator x plus 2x square root, my bad, minus 2 square root of x minus 4. Where am I getting these numbers? just as I'm getting it from distribution. Negative. Okay. Since I clarified that, since these two have similar coefficients or similar numbers in front and same variables, technically, they're like terms, basically what I'm trying to say. Um, would equal to 0. So we don't have to add 0 in this equation. So x will be less than or equal to 4. We could have done this even faster if we, since this is a difference of squares, we would have had a negative 2 or 2 to the power of 2. And since the square root times the square root, uh, it loses its square root. Because if you think about it, it's basically adding two one halves, or yeah, 2 1/2, and this would equal to 2 over 2. I don't know what happened there. 2 over 2, which will equal to 1. So that's why x will be by itself. It would not have a radical. Okay, so this is our expression. And remember, we still have the radical. X plus 2. This one right here. We don't have to factor it out, since these two are common factors. We can divide it, and this will equal to 1 times square root of x. I forgot to limit of x, which is 4. X, I don't know what happened there. The limit of x, which is 4, 1 times 2 square root. Now we can substitute, because if I were to substitute it here earlier on, we would have had an indeterminate. And actually, I'm not really sure if I did double check it. Yeah, we would have an indeterminate. We cannot have a 0 divided by 0. That means we have to algebraically manipulate this. I know I'm skipping the lesson, so I'll give you a preview here. And we're almost done. We just have to substitute. So what's the limit of f of x? Yes, f of x, which is 4. F of x is represented by this function of this function. We can substitute it. I'm just going to do it here in my work. Square root of 4 is equal to 2, and 2 plus 2 is equal to 4. So it's going to be 4. And your only answer choice with 4 would have been C. I don't know why I was trying to circle the whole thing, but I could have just circled C. Thank you for watching, and I hope you enjoyed the video. Have a great day.